Good afternoon, students. Today we start the new chapter in chemistry, that is solid state. Now we came to know that there are the various substances which generally we come across in our daily life. These are the solid, liquid and gases. Now we know that the solids are totally different from liquid and gases because in liquid and gases they have fluidity, that is they can flow, and hence these are known as the fluid, whereas the solid, they do not possess fluidity. Instead of fluidity they have rigidity. This means that the constant particles, they are not free to move, and the constant particles, they have fixed position and can only oscillate about their mean position. Thus we can state that solid is defined as that form of the matter which possesses high rigidity and hence possesses definite shape and definite volume. For a particular substance to act as a solid, liquid or gas, there are the net forces, the opposing forces which will decide what type of the substance is formed. Number one, that is the intermolecular forces, and number two is the thermal energy. Intermolecular forces, these are the force which are existing among the constant particle and try to keep the constant particles close together. Second is thermal energy. This is the energy which is possessed by the constant particles due to rise in temperature. This energy tries to keep the constant particles apart as it tends to move faster. As we know that in case of solids, the constant particles are closely packed. The intermolecular distances are very small. The constant particles occupy a fixed position and they can oscillate about their mean position. Therefore, the solids have high rigidity, definite shape, definite size, definite volume. They possess high density. They are incompressible and the constant particles are fixed over their mean position. Types of the solids. There are two types of the solids. Number one, crystalline solid, and number two, that is amorphous solids. Now in crystalline solids, we can also include the metals, non-metals and the certain compounds. They have to exist in this form. While in case of amorphous solid, rubber, glass, pitch, tar, fused silica, plastics and polymers of the high molecular masses are present in the case of amorphous solid. As we know that in the case of the solid crystalline, the various constant particle, that is atom, ion and molecules, they are arranged in a definite geometric pattern in three-dimensional space, so that there is a short range as well as the long range order of the constant particle. On the other hand, a solid is said to be the amorphous if there is no regular definite geometrical pattern of the constant particle in three-dimensional direction. Therefore, these are only the short range order of the constant particles. Number two, that is the melting point. The crystalline solid, they possess the sharp melting points. The crystalline solid possesses sharp melting points, whereas the amorphous solid gradually melts at over a various temperature range. Anisotropy and isotropy. In case of amorphous solid, the properties like electrical conductivity, refractive index, thermal expansion, all are having identical property in all the direction. Therefore, this property is called isotropy, and the substance showing this property is known as isotropic substances. Therefore, all the amorphous solids, they are isotropic in nature. On the other hand, in the case of crystalline solid, the property like thermal expansion, refractive index, electrical conductivity, they possess different properties, they possess different value in the different direction, which is called anisotropy. Therefore, the crystalline substances show their anisotropic behavior. Next, that is cleavage with knife. When a crystalline solid on being cut with a sharp knife, we get the clean cleavage edges are obtained. Whereas in case of amorphous solid, irregular edges are obtained. Heat of fusion. The crystalline solid possesses the definite heat of fusion, whereas amorphous solid do not possess the definite heat of fusion. Cooling curves. The cooling curves of the amorphous solid is smooth without any break. Whereas in the case of crystalline solid, the cooling curves are not smooth. As we lower down the temperature, then we will observe that the sharp points are obtained where the solidification starts and where the solidification is completed. Therefore, we are not getting the smooth curve in the case of the crystalline solids. Next, the amorphous solids are considered to be supercooled liquids because of very high viscosity, and they are also known as the pseudo solids. Whereas the crystalline solids are known as the true solids. Now, the crystalline parts in the case of the amorphous solid are known as crystallites. Both diamond and graphite are the example of the crystalline solids. As we know that a material like that of SiO2, which is known as the silica, on silica crystallizes as a quartz, in which the SiO4 tetrahedron are linked in a regular manner, but on melting and then rapidly cooling, it gives glass, in which the SiO4 tetrahedra are randomly joined to each other. Thus, quartz is the crystalline solid of SiO2, whereas glass is the amorphous solid of SiO2 unit. And we know that one carbon atom is attached with three other carbon atoms in their ring structure, due to which each electron of each carbon atom in the hexagonal ring is free to move. Therefore, graphite is a covalent solid. It is soft, good conductor of electricity. It have exceptional behavior due to its typical structure, and in this structure, the fourth electron of each carbon atom is free to move. Because of the presence of this free electron in the different layer, the graphite become good conductor of electricity that we not observed in the case of diamond. These are the few examples of the differences between the crystalline and amorphous solids. Now, how many types of the crystalline solids are there? The next topic is types of the crystalline solid. As we know that in this table, the four different types of the crystalline solids are mentioned. First one is that is known as ionic solid, molecular solid, covalent solid, and metallic solid. Here in this table, first we explain the molecular solids. The molecular solids are divided into three parts, that is nonpolar, polar, and hydrogen bonded molecular solid. Now, what are the constant particles of these? The constant particles of the nonpolar molecular solids are atoms of the noble gases or the nonpolar molecules. While the force of attraction, the nature of the binding forces which are present between them is London dispersion forces. Examples are argon, hydrogen, H2, I2, solid CO2, and they are soft, they are insulator, the melting points are very low and low density and volatile. Second is polar molecular solids. The polar molecular solids generally contain dipole-dipole force of attraction. Examples are HCl polar molecule, SO2 polar molecules. They are also soft, insulator, their melting points are low. Third one is known as hydrogen bonded molecular solids. Here the constant particles are the molecule containing hydrogen atom which is linked with fluorine, oxygen and nitrogen. The nature of the bonding is hydrogen bond. Examples are H2O, ammonia. They are also soft, insulator, and their melting points are low. The second one is known as ionic solids. Ionic solid, the constant particles are positive or negatively charged ions. and the force of attraction between them is the Coulombic force, which is also known as the electrostatic force of attraction. Here the examples are NaCl, MgO, ZnS and calcium fluoride. They are very hard but brittle, or they are insulator in solid state but conductor in molten or aqueous solution. Their melting points are high and they are soluble in the polar solvents, and they are insoluble in non-polar solvents. And third one is known as the metallic solids. The metallic solids, their constant particles are positive ion in the sea of mobile electrons, and the force of attraction between them is the metallic bond. All metal and alloys, their nature is hard. They are the conductor in solid state as well as in the molten state. Their melting points are fairly high and their property malleable and ductile and possess good luster.